So yes, I'm going to use about a V model and how we use it in the automotive industry for software development. But in general, we are developing systems. As you see, it stays vehicle occupant safety systems. This is the also called airbag system in the vehicle, but it not just deploys the airbags, the belt engineers are belonging to here as well, or we can send out error messages or emergency calls or something like that. So this kind of functions also built in. So I might mix these two words, system development and software development, because we do both, and within the system we have algorithm, software application, and also hardware and mechanical development. It's usually included, not all the projects, but general. Okay, what do we have here, and why is it so important to to develop these systems? On the picture, you can see 4 different types of crashes, and so the impact, what you can see, is totally different. On the top left corner, that's a frontal crash, and in this case, in order to protect everyone inside the car, the front airbags need to be deployed. Here you can see a side crash where there is no need for any kind of frontal airbags. The side bags and the curtain bags are the ones which are protecting the people. And on the third picture, you can see we call it a rollover event. As you see, at this point, the vehicle is not even deformed, but already the curtain bags and the belt engineers need to be deployed. So the vehicle needs to recognize the event and act accordingly. And to make these decisions, it's it's crucial that we must have a reliable system that detects it and can make a reliable decision based on the inputs. On the fourth picture, that's interesting. It's not even about protecting the people inside the vehicle. In some car brands, it's even it's an emerging topic that also the cyclists or pedestrians need to be protected. Altogether, we call them as vulnerable road users. And in this case, the car needs to recognize that what I hit is not a barrier, not a wall or a tree or another car, but it's only a passenger, and no one is in danger inside the vehicle, but the people outside of the vehicle are in danger. And what we deploy or what we do after making these decisions, you can see frontal airbags deploying, or in this picture, you can see almost every kind of airbags. There are also, let's call interaction bags between the driver and the passengers, so their heads are not hitting each other. Nowadays, there are even bags inside the belt or in the cushion. So there is a headrest bag. If there is a rear accident, then your neck is not hurt that much. And you can also see the the other restraint system. So the belt plays a crucial role here, and it's so the system can protect you the best if you are buckled and the belt and the airbags can function together. And an interesting question: do you have any idea how fast could it be? How much time should we make these decisions, deploying the bags, and which ones? Guesses, any kind of guesses are welcome. Milliseconds? In milliseconds, yeah, that's the unit is good. Yeah, 5. It's a good. Tens, yes. As to compare to something, a blink of an eye lasts for 100 milliseconds. So the 5 is quite an interesting guess, and yeah, and it's true. I would rather say 10 milliseconds in case of front crashes, but in case of a front crash, you have a big deformation zone, and that lasts for a lot of time. That yes, you have time. You could say yes, and in case of side crashes, for instance, that 5-6 milliseconds is a totally normal time for making the decision, and then after 10 more milliseconds or something like that, the airbags are fully inflated. Yeah, and in such fields where we need a reliable software, and what we are developing is highly safety critical. In those fields, the V model is an often used method. It's a development lifecycle methodology, and if it got the name from the shape. It has a shape of a V, and if you imagine on an agile to waterfall scale, what do you think? Where does it belong to? To the left, right, middle, or where? Which one does it similar to? Do you have any guesses?
I would say more closer to the waterfall one.
Let's see. Yes, good one. Yes, it's also called as an extension of the waterfall method. The steps are coming after a sequence, and usually there is a delivery on only at the end, when we start from the top left and we make the V, and the delivery is only at the end. Let's go in deeper. Yes, you see the V shape, and there is on every level there is a line, a dashed line, which means the connection between the design phases and the testing phases. And this is its I would say the strength, that to every requirement we can link directly a test, and then we can say that okay, this is fulfilled, and we tested it as well. Let's start with the first step, or I would say step 0, the requirement analysis. It's crucial to have that done, because if we start doing the development and at the end or in the middle new requirements are coming, or we realize that we didn't understand fully those requirements which we received at the beginning, then we need to go back to step 0. And it's also usually it is a strong discussion among the suppliers and the car manufacturers. So they send us a list of requirements in any kind of form, and we never say that, okay, accepted, we do it. We always need to go back to them and say, okay, I saw this sentence. When you wrote this, did you mean this, or did you mean that? Or you haven't covered all the possible scenarios. What would you do if this and this and this criteria happens? And they very often say that, "Ooh, thank you, that's a really good point. I haven't thought about that. I need to check that, and we need to cover that." And they highly appreciate these feedbacks. Once it also happened to me that I work with a car producer which has a development center in Germany and also in Austria. And usually I work with the German ones, but on one project I worked with the Austrian ones, and they sent us a list of requirements, and we said, okay, let's check them. And they were foggy and not no one could understand, and it was not thorough enough. So we organized a meeting and asked them, okay, how did you think it? Why? What does this mean? Or how should we handle them? And they said at the very beginning of the meeting that, you have a good point. Honestly, we don't really know how to formulate these requirements, but we want exactly that, what you did 1 year ago to the German colleagues. And we said, okay, then let's talk to those German development center and see what was their requirement, and then we can, of course, implement the same thing again. But in this time, they didn't have this information, so I asked the main project manager, and in this time, reflecting to Peter, I asked for permission if I can send them, and then they said, okay, no problem, I can send them. And then I sent them the requirements, and then they sent us back in an official way, so we could start doing the project. As I also have some negative examples, sadly, but it also happens sometimes that we we receive the requirements, analyze them, understand everything quite well, and start doing our job. And in the middle, during the implementation phase, once happened that the customer asked for a behavior change in the side airbag deployment, and we were already in the implementation phase when they said, "Oh, and a bit of front airbag change," and we were like, "Okay, it's not what we were talking about before," but we could go back to them and could negotiate, and they really appreciated the openness from our side, because we didn't say, okay, go back to step 0 and start everything over. We said we did quite a major job so far, and what you ask on top of it, it's not that much, so we could handle faster that, and they were really appreciating that. Let's go back. Here, this is a top-down phase. We have a higher level designs and then go back to lower level designs. Here, several disciplines are working together, and then we need to decompose which requirement or which module is covered by whom. So here the disciplines are working quite close to each other, and we are sorting the task, who is handling what. Then we are coming to the so this part doesn't necessarily have to be from 3 steps. So every company can tailor it to themselves, and they know how complex their project is or how complex their product is, and they can fit into 2 steps or even sometimes 1 step. And then we are coming to the implementation or coding phase. Usually this is the longest one, I would say, but it only starts here in the middle. So this is sometimes it can be seen as a weak point or a negative side if we compare it to the agile methodology, because until this point no one is done basically. So the from coding point of view or from implementation point of view, we didn't do anything until this point. But on the other hand, at least at this point, we fully know what we want to do and we know what we want to achieve. And then we are coming to the testing phase. Here, what is visible on this on the V shape, that every test is covering the necessary. So every level covers the necessary testing on each. Connecting to each design phase. So we do the unit testing first and test smaller packages, and if we see any kind of bug, then we can make smaller recursions. Of course, they are never welcome, but the smaller the recursion is, the better it is for us at the end. Then comes the integration testing and system testing, and what is important that we have these lines, and it's good from project management point of view and quality point of view. We have every requirement link to every test. So at the end of the project, we can say, okay, we have this requirement, we decomposed it to our level or our language, and we implemented it and tested it. And there are direct links between the 2 sides of the V. And we are going back to the top. This verification phase about the testing, and then comes the validation phase. It differs on the industry, but in case of airbag systems, the validation is when they flash the software onto the cars. These are usually prototype cars, and they bring them to the crash test, put on a lot of sensors on it, and put these plastic dummies inside the car, put sensors everywhere on the dummies, and then they crash to the wall and see if they have that 5 milliseconds deployment time or 10 milliseconds deployment time or what. And they also detect the deformation of the dummy. So it can happen that what they gave us as a requirement, that 10 milliseconds is not enough, or even sooner deployment is needed because the dummy had such a severe injuries that it's a no-go. At the end, there are some companies which are making these safety ratings. This is called, the abbreviation stands NCAP. They are the ones who are, at the end, they are giving you a percentage. Everyone can check their car. If you search it on the NCAP, you can see either in the past there were stars, so 4-star, 4.5 star, 5-star. Now they start to sophisticate it, and then you see a percentage, so 92% or something like that. And there are even tests which are regional specific, so they are coming from regional regulations. So until the OEMs do not carry out those tests, they are not allowed to sell cars in that specific region. And yeah, after that, the handshake is coming, but it's also funny, as I mentioned, there are several types of releases. So at the very beginning, we are just releasing a system which they can flash on the car, and then they see if there is an error message or not. And that's the only thing what that can do. After that, we are becoming more mature, and we are doing several loops on the V. There are then the prototypes which are allowed to crash in the crash tests. There are a middle phase when only trained drivers can drive the car around in circles in a closed facility or their test tracks. And at the end, when the validation is done, then we can say, okay, it's a series system or series software, and it is released. Yeah, and it's up to the customer how many releases they want and for what they are using it. Sometimes it happens to us that couple of months ago, main project manager was pushing us really hard because there was a 2 days of delay, and he said it's not acceptable. How will he tell it to the customer that we are in 2 days of delay? And in my position, I'm in close contact to the car manufacturers, so I regularly talk to them, and they never asked about that deadline, and they never asked about that specific prototype delivery. And once I asked them, okay, the deadline is coming and you never ask about the status, how come, how is it possible? And they told me that because, Mr. Szendrei, we don't need that delivery. Your project manager told us, you, from your internal process, you need to deliver it, but we won't use it for anything. And then I said, okay, then it's not a problem if it's late 2 days, right? And they said, yeah, perfect. 2 days later, perfect. We still won't do anything with it. And then I could tell it to the project manager, and he was then happy and relaxed at the end. Yeah, let's summarize what are the pros and cons of this development methodology. This is a disciplined method, so it can reduce the risks. It is easy to track, so to any kind of project manager who is not that close to the product, we can point on the V, somewhere in the V, and say, we are here, and this is the things we should do in the future. And it's also easy to plan, so we can start even the planning in the design phase, and we can tell in a very early phase how much testing we need and how long will it take to do them. And as I mentioned, the test coverage is visible, which is really important in safety critical developments. But it's not a flexible one and requires a lot of documentation. But yeah, in these fields, it's inevitable that we need to do a lot of documentation. And if we face unclear requirements, then it is really a problem. So we need to clarify them in the first step. And yes, at the end, we receive quite late feedback from the customer, but it is coming from the nature of the development that we cannot really give interim softwares because that could harm more than help. Yes, and I'm close to the end. I think I was talking 30 minutes, almost 30 minutes. And if there is one single information you are taking with you. My suggestion is that it should be that you always need to fasten your seatbelt, because this is the best way these systems can protect you. It doesn't matter how hard I'm working or my colleagues are working, if you are not buckled, even in the rear seat or even with low speed, this always helps you.